The air is thin and cold, above 15,000 feet. At Wright Field, Ohio, in the summer of 1942, a test pilot levels off the brand-new XP-51. The aircraft is a marvel of aerodynamic design, the sleekest, most advanced airframe America has yet produced. On the ground, its Allison V1710 engine has a throaty, powerful roar. But up here, in the thin atmosphere where the war is actually being fought, the engine gasps. The pilot pushes the throttle, but the horsepower bleeds away with every foot of altitude gained. The plane struggles, its controls feel sluggish. It is a racehorse suffocating in a vacuum. This machine, ordered by the British and evaluated by the Americans, is not a breakthrough. It is a disappointment. The P-51 Mustang, an aircraft that would become the single greatest icon of American airpower, was born a profound failure. Its revolutionary body housed a crippled heart, the Allison V1710 engine, a power plant that made it useless for the very war it was destined to win. This is not a story of American ingenuity alone. It is the story of an Anglo-American gamble, a desperate engine swap that transformed a grounded thoroughbred into the apex predator of the skies. This is the story of how the P-51 Mustang failed before a British engine made it a legend. The genesis of the Mustang was a desperate plea from abroad. In 1940, the British Purchasing Commission, chaired by Sir Henry Self, approached North American Aviation, NAA, to build Curtiss P-40 Warhawks under license for the Royal Air Force. NAA's president, James Dutch Kindleberger, made a counteroffer that was audacious to the point of arrogance. He claimed his team could design and build a completely new fighter, superior to the P-40 inches every way, in just 120 days. The British, in dire need of any aircraft, agreed, and the NA-73X project was born. NAA's chief designer, Edgar Schmood, a German-born engineer who had previously worked for Messerschmitt, poured cutting-edge theory into the design. The most significant innovation was the laminar flow wing. Unlike conventional wings, this airfoil was designed to maintain smooth, or laminar, airflow over a much larger percentage of its surface, dramatically reducing drag. This, combined with a revolutionary ventral radiator scoop that actually used the heat it was exhausting to produce a small amount of jet thrust, the Meredith effect made the airframe a masterpiece of aerodynamic efficiency. On paper, it was the fastest thing in the world. But an airframe is only half a fighter. The other half is the engine. The British contract had specified the Allison V1710. At the time, it was America's only liquid-cooled, high-performance fighter engine in mass production. It was the power plant for the P-40, the P-38 Lightning, and the P-39 Airacobra, and it had one catastrophic, defining flaw. The problem was not the engine itself, but its supercharger. At sea level, an engine ingests air at normal atmospheric pressure. At high altitude, the air is far less dense, starving the engine of oxygen. A supercharger is an air compressor, mechanically driven by the engine, that forces compressed air into the cylinders, tricking the engine into thinking it's flying at a much lower altitude. The Allison V1710 was equipped with a single-stage, single-speed supercharger. This was, in essence, a simple gear-driven fan. It was optimized for maximum efficiency at a specific, medium altitude around 12,000 to 15,000 feet. Below that altitude, it was a world beater. Above it, it was an anchor. The British were the first to find out. The RAF received its first Mustang in November 1941 and promptly sent them to the Air Fighting Development Unit, AFDU, at RAF Duxford for evaluation. The reports that came back were a mixture of exhilaration and profound disappointment. At low altitude, it was a revelation. It was faster than a Spitfire V, more agile than a P-40. But the test pilots noted with alarm what happened when they climbed. As one AFDU report from April 1942 stated, the Mustang I was unsuitable for employment above 20,000 feet. Its performance, they wrote, falls off rapidly above 15,000 feet. In combat, this was a death sentence. The strategic air war, the high-stakes bombing campaign against the Reich, was being fought at 25,000 to 30,000 feet. At that altitude, a Messerschmitt Bf 109 or a Focke-Wulf 190, both equipped with advanced superchargers, could fly circles around the breathless Allison Mustang. The RAF relegated their new wonder plane to low-level tactical reconnaissance and ground attack, missions it performed admirably under the Army Cooperation Command. It was a good aircraft, but it was not the high-altitude pursuit fighter the Allies desperately needed. The statistical hammer of this failure is found in the horsepower curves. The Allison V171039 fitted to the P-51 Amperes was rated at 1,150 horsepower at 11,800 feet. By the time it reached 20,000 feet, that power had fallen off a cliff. Meanwhile, a Rolls-Royce Merlin 61, fitted to the Spitfire 9, was equipped with a revolutionary two-stage, two-speed supercharger. This was essentially a gearbox for the supercharger, allowing the pilot to select a low gear for medium altitude and a high gear for high altitude, keeping the engine breathing dense air. This Merlin was rated at 1,565 horsepower at 12,250 feet, but in high gear, it could still produce over 1,380 horsepower at 21,000 feet. The Allison engine wasn't just outperformed, it was rendered obsolete. The USAAF, which had received two models as the XP-51, came to the same conclusion as the British. They saw an airframe with revolutionary potential, shackled to a power plant that was fundamentally unsuited for the European theatre. The P-51 was a thoroughbred stallion, a champion in the making, but it had been born with crippled lungs. It was an aircraft designed for a war that was no longer being fought, a high-speed, low-altitude interceptor in an arena that demanded high-altitude, long-range escorts. The entire P-51 program, North American's 120-day miracle, was on the verge of being relegated to a footnote. It was a failure. But one man, a British test pilot who had seen both the Mustang's flaw and its potential, was about to make a suggestion that would change the course of the air war. RAF Duxford, April 1942. The Cambridgeshire sky is a watercolour grey. A new aircraft, painted in RAF roundels but unmistakably American in its sleek, muscular design, taxis to a halt. The pilot, Ronald W. Harker, shuts down the Allison engine and unstraps his helmet, his mind racing. Harker is not a typical RAF pilot. He is a Rolls-Royce man, a liaison test pilot whose job is to evaluate engines, not just airframes. He has just flown the new North American Mustang 1, and like every pilot before him, he has experienced a profound duality. Below 15,000 feet, the aircraft was a revelation fast, agile, a thoroughbred. But as he climbed, he felt the power die, the Allison engine gasping for air, the stallion becoming a draft horse. Other pilots had simply filed their reports, damning the aircraft to a life of low-level reconnaissance. Harker saw something different. He saw a perfect airframe being strangled by an inadequate engine. He saw a solution. Back in his office, he did not just file a standard flight report. He wrote a memorandum, dated the 30th of April 1942, that would change the history of aviation. It was addressed to his superiors at Rolls-Royce, specifically to the legendary engineer Ernest Hives. The memo was a masterpiece of professional observation and radical suggestion. Harker praised the airframe with undisguised enthusiasm. "In my opinion," he wrote, "the Mustang airframe is outstanding, and the fitting of a Merlin 61 series engine would, I am sure, produce a winner." He didn't stop there. He laid out the performance data of the Allison, its critical drop-off in power, and contrasted it with the known capabilities of the Merlin 61. He estimated that a Merlin-powered Mustang would be some 40 meters, ph, faster than the Spitfire V at 30,000 feet. He concluded his memo with a simple, powerful plea. The point I wish to make is that a high-altitude version of this aircraft with the Merlin 61 would be a good thing and is well worth some scheming. Well worth some scheming. This was a colossal understatement. What Harker was proposing was not a simple tune-up. It was an industrial and engineering gamble of the highest order. The Merlin 61 was not just any engine. It was the crown jewel of the British war effort, the single most critical piece of technology in the RAF. Its two-stage, two-speed supercharger was the brain and lungs that allowed the new Spitfire 9 to finally meet and defeat the Focke-Wulf 190, the butcher bird that had terrorized the skies over France. Every single Merlin 61 rolling off the assembly lines at Derby and Crewe was earmarked for a Spitfire. Harker's memo landed on the desk of Ernest Hives, Rolls-Royce's formidable general manager. Hives was a pragmatist, an industrial giant who believed in results, not bureaucracy. He read Harker's report and immediately grasped the implications. He didn't wait for ministry approval or committee meetings. He trusted his test pilot's assessment. Hives performed his own back-of-the-envelope calculations and saw the same potential. He famously declared, "Give the Mustang a Merlin, and it'll bloody well go." On Hives's authority, Rolls-Royce immediately began what was, essentially, a secret, off-the-books project. They acquired 5 Mustang 1 airframes from the RAF serial numbers AG 518, AL 963, AL 975, AM 203, and AM 208. And at their Hucknall flight test establishment, Chief Designer Ray Robotham and his team began the immensely complex task of scheming. They codenamed the project Mustang X. This was far more than just unbolting one engine and bolting in another. The Allison V1000, 710, and the Rolls-Royce Merlin were entirely different beasts. The Merlin was slightly smaller in displacement, but, with its superior supercharging, vastly more powerful at altitude, and it produced far more heat. The Mustang's revolutionary ventral radiator system, designed for the Allison, would have to be completely re-engineered. The engine mounts were different, the propeller was different. The entire power egg, the cowling and all its intricate connections for fuel, oil and coolant had to be redesigned from scratch. The British engineers were, in effect, performing open-heart surgery on an American patient, with no guarantee the patient would survive the operation. While the engineers at Hucknall cut metal, the political battle began. The Ministry of Aircraft Production was, to put it mildly, skeptical. They were in the business of mass production, and this experimental hybrid threatened to disrupt the carefully balanced flow of the all-important Spitfire line. Why waste precious Merlins on an unproven American airframe when the Spitfire 9 was already a war winner? Furthermore, the Americans had to be convinced. The USAAF was already sensitive about the performance of its Allison engines. Suggesting that their newest fighter was a failure without a British engine was a delicate diplomatic affair. The USAAF was in fact already working on its own time solution, a P-51 variant, the XP-51 Farrads, and, more urgently, an upgraded Allison V1710 with a 2-stage supercharger, but this was months, if not years, away from production. The British lifeline, extended by Ronald Harker's keen eye, was a radical, almost heretical idea. It challenged industrial policy, national pride, and established logistics. But it was now in motion. The Mustang X aircraft, crude hybrids built in a British shed, were being prepared for their first flights. Everything now depended on that British engine, the masterpiece of engineering that Harker had bet his reputation on. The fate of the P-51, and perhaps the air war itself, now rested on the geared heart of the Merlin. It is not merely an engine, it is a 27-litre, 1,700-pound masterpiece of metallurgical science and engineering precision. The Rolls-Royce Merlin 61 is a V12 Leviathan, a symphony of precisely machined gears, hardened alloys, and intricate plumbing. But its true genius, The component that made it a war winner is not its size or its 1,500-plus horsepower. It is a piece of machinery bolted to its rear, the revolutionary two-stage, two-speed intercooled supercharger. This device, more than any wing or cannon, was the heart of the Merlin, and it was the key that would unlock the Mustang's future. To understand what the Merlin did, one must first understand the work of a brilliant, and initially overlooked, Rolls-Royce engineer named Stanley Hooker. In the late 1930s, Rolls-Royce, like Allison, was focused on single-stage superchargers. The company's official policy, driven by Ernest Hives himself, was that high-altitude performance was a secondary concern. Hooker, a mathematician by training, disagreed. He had studied the problem of forced induction and became convinced that a single-stage blower was a dead end. He calculated that to get meaningful boost at 30,000 feet, a single-stage supercharger would have to spin so fast that it would either melt, draw too much power, or be hopelessly inefficient at lower altitudes. Hooker's solution, which he developed almost in defiance of company directives, was the two-stage, two-speed system. It was, in essence, a mechanical gearbox for the atmosphere. The system featured not one, but two impellers, the two-stage part. In low gear, the two-speed part, activated by the pilot at lower altitudes, the engine would draw air through the first impeller, which compressed it. This was adequate for flying up to a fulcrum altitude of around 18,000 to 20,000 feet. But as the air thinned, the pilot would engage a clutch, and the magic would happen. This engagement, described by countless RAF pilots, was a tangible, physical event. In his memoirs, one Spitfire pilot described it as a distinct kick in the back. He would be climbing, the engine's power fading just like the Allison's, and then, at the critical altitude, he would engage the high-gear blower. The engine note changed, he recalled. It took on a harder, more urgent scream, and the aircraft surged forward as if it had been given a new lease on life. This was the second stage kicking in. The air, already compressed by the first impeller, was now rammed into the second, higher-speed impeller, compressing it again. This twice-compressed air was then cooled by an intercooler, another critical innovation, as compressed air is hot and less dense, before being fed into the Merlin's cylinders. The engine was now breathing a dense, oxygen-rich charge, as if it were flying thousands of feet lower. The Allison's power curve fell off a cliff, the Merlin's hit a plateau, then climbed times again asterisk. The statistics were staggering. The Merlin 61 could produce over 1,300 horsepower at 21,000 feet, an altitude where the Allison V1710 was producing less than 700. This was the kick in the back that Ronald Harker knew the Mustang airframe was crying out for. But this performance came at a cost, not just in pounds sterling, but in man-hours. The Merlin was a craftsman's engine. Rolls-Royce, at its Derby and Crewe factories, was not a mass-production outfit in the American sense. Its workforce was comprised of time-served artisans, men who hand-scraped bearing surfaces and measured tolerances in fractions of a thousandth of an inch. The gears of that two-speed supercharger had to be cut with the precision of a Swiss watch, capable of spinning at over 20,000 revolutions per minute without disintegrating. As Stanley Hooker himself noted, the problems were not all aerodynamic, they were mainly mechanical. The forces on the driving gears were formidable. This created an industrial bottleneck that defined the British war effort. In 1942, Rolls-Royce was struggling to produce enough Merlins for its own time's top priority aircraft, the Spitfire 9 and the Mosquito. The Spitfire 9 was the only aircraft in the RAF inventory that could reliably fight the foe 190, and the Mosquito, the wooden wonder, was a jack of all trades that was proving indispensable. The idea of diverting hundreds, let alone thousands, of these priceless, hand-built engines to an unproven American airframe was, to many in the Ministry of Aircraft Production, industrial lunacy. The Mustang X experiments at Hucknall only proved this point. The first of these hybrids, serial number AL 975, took to the air on the 13th of October 1942, piloted by Rolls-Royce's chief test pilot, Captain R.T. Ronnie Shepherd. The results were electrifying. The aircraft was a rocket. It leaped to 20,000 feet in just over 6 minutes, half the time of the Allison-powered original. It clocked a top speed of 433 miles per hour at 22,000 feet, nearly 70 miles per hour faster than the P-51 Amperes at the same altitude. The gamble had paid off. Harker's scheming had produced, as he predicted, a winner. But the success of the Mustang X only highlighted the larger crisis. The hybrid was a success, but it was a boutique-built prototype. Britain had the perfect engine. America had the perfect airframe and, more importantly, the industrial capacity to build it by the tens of thousands. The RAF simply could not spare the Merlins. If this new superfighter was to exist in numbers large enough to affect the war, the problem was no longer one of engineering, but of logistics. The British heart, forged in the craft shops of Derby, would have to be taught to beat in the mass production factories of America. The success of the Mustang X experiments in the autumn of 1942 was a moment of profound triumph and immediate crisis. Ronald Harker's scheming had produced a war-winning aircraft, but the celebration was short-lived. The Ministry of Aircraft Production, facing the brutal realities of logistics, delivered the bad news. There were no spare Merlins. Every single engine coming out of Rolls-Royce's overcapacity factories at Derby and Crewe was critically needed for the Spitfire 9 and the Mosquito. The Royal Air Force could not, and would not, divert its most vital asset to an American airframe. The Mustang's new heart was perfect, but it was unavailable. The solution, it turned out, was not in England. It was in Detroit, Michigan, at the Packard Motor Car Company. Packard was a name synonymous with American luxury, the builder of opulent, hand-finished automobiles for the wealthy. It was not an aviation company. But in 1940, long before the Mustang X flew, the British Purchasing Commission under Sir Henry Self had foreseen an existential crisis. They needed a second source for the Merlin, and they needed it in a place with the industrial might to build it on a scale that Britain, even at full stretch, could never achieve. They first approached Ford, but Henry Ford, an avowed isolationist, personally refused to build engines for a foreign war. Desperate, the commission turned to Packard. The company's president, George T. Christopher, saw both a patriotic duty and an immense engineering challenge. He accepted. The deal that was struck was one of the most significant technology transfers in history. This was not a simple licensing agreement. Rolls-Royce didn't just send blueprints. In an act of profound trust, they sent several complete pattern engines, masterpieces built at Derby, to be disassembled, studied, and reverse-engineered. More importantly, they sent a team of their best production engineers, led by Arthur Rubra, to live in Detroit and personally guide the translation of a British artisan's engine into an American mass-produced product. The man tasked with this monumental effort at Packard was Jesse G. Vincent, the company's chief engineer. Vincent and his team quickly discovered that the challenge was far greater than they had imagined. The Rolls-Royce blueprints, they found, were often a guide, not a gospel. They were based on a British craft system where a skilled fitter at a workbench would hand-scrape a bearing or file a part to a perfect fit. The drawing might list a tolerance, but the real specification was in the hands of a master craftsman. American mass production, the very system Detroit had invented, was the opposite. It relied on absolute unyielding precision from the blueprint. Every part had to be 100% interchangeable, built by a machine, and assembled by a worker who might never have seen the final product. Vincent's team had to redraw over 10,000 unique parts for the Merlin. They had to translate British Whitworth threads to American SAE standards, British metallurgical specifications to their American equivalents. As Jesse G. Vincent himself later recalled, "We were not just copying an engine, we were re-engineering it for American production. They had to invent new processes, new tools, and new quality control methods to replicate British handiwork with American machines. The single greatest challenge was the crown jewel of the Merlin, Stanley Hooker's two-stage, two-speed supercharger. The high-speed impeller and its intricate gearbox were, as one Packard engineer put it, a Swiss watch built to withstand explosions. The gears had to be perfectly cut and balanced to spin at over 20,000 revolutions per minute without disintegrating. Rolls-Royce achieved this through a slow, meticulous process of gear hobbing and hand finishing. Packard had to build thousands of them a month. This required a revolution in tooling. Packard invested over $100 million, a staggering sum in 1941, to tool up its Detroit factory, inventing new automated gear-grinding machines and metallurgical processes to forge and harden the components with a precision that rivaled, and in some cases exceeded, the originals. By late 1942, just as the Mustang X was proving the concept in England, Packard's new production lines were roaring to life. The American-built engine was designated the Packard V1650. The V for its V12 configuration, and 1,650 for its displacement in cubic inches, equivalent to the Merlin's 27 litres. After overcoming severe initial teething problems, the V1650 was a triumph. It was a robust, reliable, Americanized Merlin, capable of being torn down and rebuilt in the field with interchangeable parts. While Rolls-Royce's output was measured in the high hundreds per month, Packard's line, once at full speed, would be churning out times thousands asterisk. Packard had not just copied a masterpiece, they had made it reproducible on a scale the Axis powers could not comprehend. The British heart, born of craft and precision in Derby, was now being mass-produced by the industrial might of Detroit. The heart was ready, available by the tens of thousands. The final, critical piece of the puzzle was now in place. The next step was the transplant surgery, this time on American soil. Inglewood, California, late 1942. At the bustling North American aviation plant, the atmosphere is electric. Telegrams and data-packed diplomatic pouches have been flying across the Atlantic. The electrifying performance data from the British Mustang X experiments, an aircraft clocking 433 miles per hour at 22,000 feet, has landed on the desks of the highest commanders in the U.S. Army Air Forces. General Henry Hap Arnold, chief of the USAAF, finally has the answer to his most pressing problem. The lack of a fighter that can escort his B-17 seconds to Berlin and back. He wants that aircraft, and he wants it now. The official tasking lands on the desk of NAA's president, James Dutch Kindleberger, and his chief engineer, Lee Atwood. The project is designated XP-51B. The order is deceptively simple: replicate the British experiment. But Kindleberger and Atwood know the truth. The British had performed a brilliant piece of ad hoc engineering on 5 airframes in a test shed. NAA was being ordered to create a Times production-ready Times design, a robust, reliable, mass-producible weapon of war, and the USAAF's Material Command, under intense pressure from Arnold, gave them an almost impossible deadline, just over 100 days. In a later interview, Lee Atwood recalled the sheer intensity of the project. The word came down to get the Merlin engine into the P-51. We were told to do it, and do it fast. This was not a simple engine swap. The British Mustang X team had proven the concept, but they had cut corners and hand-fitted parts to make it work. The NAA team had to engineer a definitive, manufacturable solution. They pulled 2 P-51 Amperes airframes, serial numbers 41 to 37350 and 41 to 37421, off the Allison assembly line, and the transplant surgery began. The challenges were immediate and immense. The Packard V16503, the American-built Merlin 68, was not a drop-in replacement for the Allison V1710. The first problem, as NA's engineers quickly discovered, was the Supercharger system. The Allison's single-stage Supercharger was compact and internally housed at the rear of the engine. The Packard, like its Rolls-Royce parent, had a massive, external two-stage, two-speed supercharger times a separate intercooler. This intercooler, a critical component the British experiments had sometimes struggled with, was essentially a radiator times for the air itself needed to cool the intensely hot charge coming from the second stage of the supercharger before it entered the engine. This entire assembly was huge. It wouldn't fit in the existing engine bay. NAA's engineers, working around the clock, had to completely redesign the entire forward fuselage. They had to create a new, deeper chin cowling to house the intercooler and its complex ducting, which fed air from the main radiator scoop. This fundamentally altered the aircraft's clean lines, but it was unavoidable. The engine itself sat on entirely new, vibration-dampening mounts, designed for the Merlin's different torque and harmonic profile. Then came the heat. The Packard V1650 produced significantly more horsepower than the Allison, and therefore significantly more waste heat. The P-51's revolutionary ventral radiator, a marvel of aerodynamics, was now undersized. It couldn't handle the thermal load of both the engine's coolant and the new intercooler. The entire radiator assembly, from the scoop's inlet to the exhausting flap, had to be redesigned, deepened, and enlarged to increase its cooling capacity, all while trying to preserve the delicate Meredith effect that gave the airframe its low drag. Finally, there was the propeller. The Allison engine's modest high-altitude power was transferred via a three-bladed Curtiss electric propeller. The new Packard V1650, churning out over 1,400 horsepower at 25,000 feet, would tear a three-bladed prop apart with sheer torque and compressibility effects. The solution was a massive 1 foot 2-inch diameter, four-bladed Hamilton standard hydromatic propeller. This new prop gave the P-51B its signature, brutal appearance and provided the bite needed to translate the Merlin's high-altitude power into thrust. It was a frantic race against time. Engineering reports from that period show a team pushed to its absolute limit, redrawing blueprints, fabricating new cowlings, and solving complex fluid dynamics problems on the fly. On the 30th of November 1942, just 102 days after the project was officially sanctioned, the first XP-51B, serial 41 to 37350, was rolled out onto the runway at Inglewood. NAA's chief test pilot, Bob Chilton, climbed into the cockpit. The flight was a revelation. All the theory, all the British data, all the frantic engineering was instantly validated. The aircraft leaped off the runway. Chilton took it up and kept climbing. He climbed past 15,000 feet, the Allison's old ceiling. He climbed past 25,000 feet. He climbed past 35,000 feet. The aircraft was not just flying, it was time's accelerating asterisk. At 30,000 feet, an altitude where the P-51 Amperes was a sluggish, wallowing target, Chilton's XP-51B was a thoroughbred. The official flight test data was staggering, almost unbelievable. The new Mustang was clocked at 441 miles per hour at 30,000 feet, over 100 miles per hour faster than the Allison-powered P-51 Amperes at the same altitude. The gamble had paid off beyond Kindleberger's wildest dreams. The XP-51B was not just a success, it was, quite simply, the fastest production fighter in the world at combat altitude. The low-level failure, the grounded albatross, had been transformed into a high-altitude predator. The reports were flashed to Hap Arnold. The response was immediate. The USAAF did not just approve the design, they ordered it into mass production on a scale that would blacken the skies over Europe. The P-51B was born, and the strategic air war was about to be rewritten. When the first P-51B Mustangs began arriving in England in the late autumn of 1943, they were met with deep skepticism. The USAAF pilots of the 8th and 9th Air Forces, particularly the newly formed 354th Fighter Group, had only heard stories of the Allison Mustang. They knew it as a low-level reconnaissance plane, an aircraft that couldn't be trusted above 15,000 feet. What rolled onto their airfields at RAF Boxted was something that looked familiar, but was viscerally different. It had a new, brutal, four-bladed Hamilton Standard propeller. It had a deeper, more aggressive chin cowling to house the Merlin's intercooler. And the sound was all wrong. The Allison's throaty, almost agricultural rumble was gone, replaced by the high-pitched, harmonic scream of the Merlin. It was the sound of a Spitfire, but it was coming from an American monster. The 354th Fighter Group, the pioneer Mustang Group, was the first to take this new hybrid into combat. The pilots, many of whom were new to the theatre, were about to discover what NAA's test pilots already knew. One of the group's most aggressive and influential leaders, Major James H. Howard, would later recall the sheer, unadulterated power. Pilots who had trained on P-47 Thunderbolts or Spitfires were astonished. The P-51B didn't just climb, it leaped. As they pushed past 20,000 feet, the altitude where their old Allison-powered trainers would have hit a wall, the P-51B times accelerated asterisk. The Merlin's high-gear supercharger kicked in with a tangible surge, and the plane felt alive. They were climbing faster, flying faster, and outturning everything in the sky. It wasn't just a good fighter. It was a revelation. The Luftwaffe's introduction to the P-51B was a study in lethal confusion. In the first months of 1944, German fighter pilots from Jägergeschwader 1 and 11, the defenders of the Reich, would spot what they believed were harmless Allison Mustangs, flying high as top cover for B-17 formations. Standard Luftwaffe doctrine was to ignore these low-level planes and concentrate on the bombers. They would initiate a high-speed dive, only to be bounced from above by a Mustang that was suddenly 100 miles per hour faster than their intelligence reports said was possible. The shock was profound, but the most damning evidence came not from combat reports, but from the Luftwaffe's own test center at Rechlin. When they eventually captured and flew a P-51B, coded T9 plus HK, their test pilots were horrified. A report from the unit, Wanda Zirkus Rosarius praised the aircraft's handling, low drag, and high-altitude performance as being a revelation. They admitted, in their own technical documents, that they had nothing to match it. The transformation from low-level failure to high-altitude predator is not a matter of opinion. It is written in the cold, hard data of engineering test reports. This is the tale of the tape. The Allison-powered P-51 Amperes was a respectable performer at low altitude, capable of reaching 390 miles per hour at 15,000 feet, but its lungs gave out. Its service ceiling was a mere 31,000 feet, and its rate of climb was an agonizing 8.8 minutes to just 20,000 feet. At 30,000 feet, where the war was being fought, its speed had bled off to an almost non-combat effective 230 miles per hour. Now, consider the Packard Merlin P-51B. Its service ceiling was 42,000 feet, 11,000 feet higher than the Allison model. It could climb to 20,000 feet in under 7 minutes and could rocket past 25,000 feet in the same time. It took the P-51 Amperes to struggle to 20,000. And the speed at 30,000 feet, the P-51B was clocked at a blistering 441 miles per hour. This was not an improvement, it was a resurrection. It was over 100 miles per hour faster at the precise altitude that mattered most. The transformation was absolute. The Allison Albatross was dead. In its place stood the most dangerous high-altitude fighter the world had yet seen. The P-51B was not an improved aircraft. It was a new weapon, a new predator. The British engine, mass-produced in Detroit and fitted in California, had finally given the 8th Air Force the weapon it had been praying for. The little friend was ready for its mission. The winter of 1943 was a time of existential crisis for the 8th Air Force. The American strategic bombing campaign, the core of its doctrine, was on the brink of catastrophic failure. The theory had been simple. Massive, self-defending formations of B-17 flying fortresses and B-24 Liberators would fly into the heart of Germany in broad daylight, absorb the blows of the Luftwaffe, and systematically destroy the Third Reich's industrial capacity. But the theory was bleeding to death in the cold, contrail-laced skies over Europe. The breaking point had come on the 14th of October 1943, a day seared into the memory of the 8th as Black Thursday. On that day, a massive raid was launched against the ball-bearing factories at Schweinfurt. The bombers flew deep into Germany, far beyond the range of their fighter escorts. The P-47 Thunderbolts, with their thirsty radial engines, had to turn back at the German border. The P-38 Lightnings, while longer-legged, were mechanically unreliable in the frigid European air and too few in number. For hundreds of miles, the bomber stream was alone. The Luftwaffe pounced. Wave after wave of Bf 109 seconds and FOA 190 seconds, supported by twin-engine destroyers firing rockets, tore the formations apart. The 8th Air Force lost 60 B-17 seconds. Another 17 were so badly damaged they were written off. Over 600 men were lost in a single afternoon. The losses were unsustainable. The daylight bombing campaign was suspended. A chilling realization settled over the high command at RAF Pinetree. In his memoirs, General Ira Eaker, the 8th's commander, was blunt. The unescorted bomber, he admitted, could not survive in the face of determined, organized fighter opposition. General Hap Arnold, in Washington, was furious. He had staked the USAAF's reputation on the daylight bomber, and it was failing. He needed an answer. He needed a fighter that could go all the way. In January 1944, Arnold made a command change. He brought in General James Jimmy Doolittle to lead the 8th. Doolittle, the man famous for the audacious Tokyo raid, was an aggressive, offense-minded commander. He arrived in England with one non-negotiable directive for his new fighter groups. The first duty of the 8th Air Force fighters is to destroy German fighters. But he knew this was impossible without an aircraft that could reach the fight. This strategic crisis was felt most acutely not in the command huts, but at 25,000 feet, in the freezing, unpressurized fuselages of the B-17 seconds. In post-war interviews, bomber crews spoke of a profound, almost primal terror. Lieutenant John C. Place Morgan, a B-17 co-pilot who would later earn the Medal of Honor, described the feeling. The terror, he said, was when you saw the little friends waggle their wings. This was the signal. The P-47 seconds, or Spitfires, low on fuel, were turning for home. Your stomach just fell out, Morgan recalled. You knew that for the next 2-3 hours you were on your own. And you knew they were coming. The arrival of the first P-51B groups in late 1943 and early 1944 was, for these bomber crews, a miracle. At first, they were just another fighter. But then, something strange happened. They times stayed asterisk. The B-17 formations crossed the border into Germany, the point where the P-47 seconds would have turned back. The new Mustangs, with their sleek, shark-like profiles, were still there. They flew past the old turnback point, weaving a protective blanket of .50 caliber death above the big friends. For the bomber crews, it was a psychological revolution. The sight of them, as one B-17 tail gunner wrote in his diary, was the most beautiful thing I have ever seen in my life. They were with us. They were all the way. This was the P-51's miracle, and it was not just a miracle of power, but of logistics. The Allison engine was not only underpowered, it was thirsty. The Rolls-Royce Merlin and its Packard-built V1650 twin was a masterpiece of efficiency. It was a high-performance engine that, when throttled back to a cruise setting, sipped fuel with remarkable delicacy. This incredible efficiency, combined with Edgar Schmood's low-drag airframe, gave the Mustang its legendary range. The industrial and statistical hammer of this victory is found in the fuel logs. The P-51B had a massive internal fuel capacity of 184 gallons, but the key was what it could carry externally. Fitted with two 75-gallon drop tanks, its total fuel load swelled to 334 gallons. This gave it a combat radius of over 850 miles. Compare this to its stablemates. The P-47D Thunderbolt, even with external tanks, struggled to effectively cover targets beyond 400 miles. The P-38 Jules Lightning, the fork-tailed devil, could stretch to 600 miles, but it was a complex, twin-engine aircraft that was a maintenance nightmare in the field. The P-51B was the only fighter in the Allied inventory that had the legs. It could take off from England, fly with the bombers all the way to Berlin, fight for 15 to 20 minutes over the target, and then fly home. It was the strategic weapon Hap Arnold had been promised, the saviour the bomber crews had prayed for. The British engine, with its combination of high-altitude power and low cruise efficiency, had delivered the one thing the 8th Air Force needed to survive. Range. The little friend was finally here, and it was ready for the ultimate test, the Big B, Berlin itself. The air offensive began on Sunday, the 20th of February 1944. Codenamed Argument, history would remember it as Big Week. It was the physical manifestation of a revolutionary new doctrine, a doctrine made possible only by the arrival of the Merlin-powered Mustang. When General Jimmy Doolittle took command of the 8th Air Force in January, he found his new P-51 seconds were still being shackled by old tactics. The fighters were ordered to fly close escort, sticking rigidly to the B-17 formations, acting as defensive bodyguards. This bomber-first doctrine, born from the terror of Black Thursday, was turning Doolittle's new predators into leashed guard dogs. Doolittle, an offensive-minded airman to his core, rescinded the order. He issued a new directive that would fundamentally rewrite the rules of air combat. His famous order was simple and brutal. Fighters are to seek out and destroy enemy fighters, go find the enemy, hunt them down, destroy them. The little friends were being unleashed. The P-51B, with its British heart and American legs, was no longer just an escort. It was an offensive, free-ranging hunter-killer, tasked with sweeping the Luftwaffe from the sky. Big Week was the first test of this doctrine, a week-long assault on the German aircraft industry. P-51 seconds, P-47 seconds, and P-38 seconds roamed deep into Germany, their primary mission not to protect the bombers, but to invite the Luftwaffe to come up and fight. The true crucible, however, was not Schweinfurt or Regensburg. It was the Big B Berlin. The capital of the Reich was the most heavily defended target on Earth, a fortress ringed by hundreds of flak guns and the elite Jagdgeschwader fighter wings, of the Luftwaffe. On the 4th of March 1944, the 8th sent its bombers to Berlin for the first time. The weather was abysmal, and the raid was a confused failure. But on March 6, they went back, this time in force. Nearly 700 bombers were escorted by over 800 fighters, the vast majority of them the long-range P-51Bs of groups like the 4th, 354th, and 357th. The battle that erupted over Berlin was unlike anything the world had ever seen. It was a swirling, chaotic, three-dimensional melee fought at 30,000 feet, leaving a sky filled with contrails, parachutes, and the black, greasy smoke of burning aircraft. The 4th fighter group, the Debden Eagles, composed of veteran American pilots who had originally flown Spitfires for the RAF, tore into the German formations. Combat reports from that day are a visceral mosaic of high-altitude violence. Pilots described diving on formations of BF 109 seconds and FW 190 seconds, the Merlin engines screaming at full power, their 50-caliber machine guns ripping apart the enemy aircraft before they even had a chance to engage the bombers. Colonel Don Blakesley, the legendary and aggressive leader of the 4th, embodied Doolittle's new doctrine. He led his fighters far ahead of the bomber stream, actively seeking a fight. His pilots found one. They described seeing the Luftwaffe stacking up in their Gefechtsverband times, battle formations, preparing for their coordinated assaults on the B-17 seconds. The P-51 seconds, with their superior speed and performance at that altitude, didn't wait. They smashed into the German formations from above and behind, breaking them up before the attack could even begin. But the Germans were not a paper tiger. They were fighting over their own capital, and they fought with skill and desperation. The Luftwaffe pilots of JG-1 and JG-26 were times expert and asterisk, aces with hundreds of kills. The new P-51 seconds, however, were their equal, and in many ways their superior. The Merlin engine gave them the power to engage, disengage, and re-engage at will, a critical advantage in a furball. A P-51 pilot, low on ammunition or damaged, could simply firewall his throttle and dive away, his low-drag airframe and powerful engine making him untouchable. The industrial and statistical hammer of this battle, and the subsequent raids on Berlin on March 8th and 22nd, was not the number of bombers lost. It was the exchange rate. On March 6th, the 8th Air Force lost 69 bombers, a horrific number, but they also lost 11 fighters. The Luftwaffe lost 80 fighters. This raw data, however, conceals the strategic truth. The Americans lost 11 pilots. These pilots were replaceable. The USAAF's vast training command in the United States was turning out thousands of new, well-trained pilots, and the factories at Inglewood and Dallas were shipping P-51 seconds by the crateful. The Luftwaffe, however, lost 80 fighters and, more critically, *65 veteran pilots times killed or wounded. These men were the irreplaceable core of the times Jagdwaffe*. They were times experten*, men who had been fighting since 1940. They could not be replaced. General Adolf Galland, the Luftwaffe's general of fighters, called this period the times Verblutung, times the bleeding. He watched in horror as his fighter arm, the elite defenders of the Reich, was being systematically, calculatingly, and irreversibly bled to death. In the 3 months from March to May 1944, the Luftwaffe lost over 1,500 fighter pilots. This was a catastrophic, unrecoverable blow. The P-51 Mustang, powered by its British Merlin engine, had done the impossible. It had taken the air war to the enemy's capital and won. It had met the Luftwaffe in its own sky, over its own capital, and had broken it. The cost was high, but the result was decisive. By the time the first Allied soldiers waded ashore in Normandy on the 6th of June 1944, the P-51 seconds had swept the sky clear. The Luftwaffe, bled white over Berlin, was almost nowhere to be seen. Air superiority over Europe had been won. The statistics tell the story of the times Luftwaffe's times collapse, but the emotional truth of this victory, the reality of the air war, resided in the cramped, freezing cockpits of the fighters. The men who flew the P-51B and its improved successor, the P-51D, were often barely out of their teens, young men from the farms of the Midwest or the cities of the East Coast, thrust into the most technologically advanced combat in human history. High over Germany, breathing pure oxygen in the thin, negative 40-degree air, their experience of the war was defined by the machine wrapped around them, and the Packard Merlin engine, thrumming just feet in front of them, was the source of their confidence, their weapon, and their lifeline. The fourth fighter group, the Debden Eagles, was a unique unit. They were veterans, many having volunteered to fly Spitfires for the RAF in the dark days of 1941 and 1942. They were experts in the Merlin engine, having flown it in their Spitfires. But they were also experts in its limitations, specifically the Spitfire's notoriously short range. They had been forced to turn back at the German border, just like the P-47 seconds, leaving the bombers to their fate. When they transitioned to the P-51B in early 1944, it was as if they had been given the weapon they were born to fly, a Spitfire's heart with an eagle's wings. Their commander, Colonel Don Blakesley, was the epitome of Doolittle's aggressive doctrine. Blakesley was a relentless hunter. In his memoirs and post-action reports, a clear tactical picture emerges. He used the Merlin engine's high-altitude performance as a strategic weapon. His 4th Fighter Group would often arrive times over times the target area at 35,000 feet, far above the B-17 seconds they were nominally escorting. From this perch, Blakesley would scan the sky below, looking for the times Luftwaffe times formations, the times Gefechtsverband times as they assembled to attack the bombers. In his old Spitfire, a dive from that altitude would have been a one-way trip. He would never have had the fuel or power to regain his altitude. In the P-51, it was the opening move. As he wrote, "We could see them, 10,000 feet below us. We'd just point the nose down and let the Merlin go." The P-51 seconds would plummet, their engines screaming in a power dive, building up immense speed. They would tear through the German formations, scattering them like pigeons, as one pilot described it. The P-51 seconds would then use their excess speed and the Merlin's raw power to haul themselves back up to their 30,000-foot perch, ready for another pass. This bounce, this ability to dictate the terms of the engagement, was a luxury the Allison-powered Mustang could never have provided. If the 4th Fighter Group were the seasoned veterans, the 357th Fighter Group, the Yoxford boys, were the newcomers. They arrived in England as a green unit, and the P-51 was their first and only combat aircraft. One of their pilots was a young Californian named Clarence Bud Anderson, who would go on to become a triple ace, flying his legendary P-51 B and D models, all named Old Crow. His memoir, To Fly and Fight, provides one of the most vivid accounts of what it was like to feel the Merlin Mustang work. Anderson describes the cockpit as a place of sensory input. He knew the engine not by its gauges, but by its sound. He wrote of the smooth, powerful rumble of the Packard Merlin, a sound that was, in his words, reassuring. He described the physical sensation of the 2-stage supercharger engaging. As he climbed past the fulcrum altitude of 18,000 feet, he would manually select the high gear blower. "You could feel a surge of power," he wrote, a distinct kick as the 2nd stage engaged. The Mustang just took off. It felt like a racehorse. This wasn't just about speed, it was about confidence. In a dogfight with a Focke-Wulf 190, Anderson knew he had a trump card. The FW-190, powered by a brilliant BMW radial engine, was a formidable opponent at medium altitude, but Anderson knew that if he could lure the FW-190 into a turning fight, or, more importantly, into a climb, the Merlin would win. He described hauling back on the stick, the Mustang's wings biting into the air, the Merlin engine at full war emergency power, and simply outclimbing his opponent. "You had confidence," he stated. "You knew. You could go anywhere they could go, and you could do it better." This absolute faith in the engine's high-altitude superiority was the P-51 pilot's ultimate psychological weapon. This view from the cockpit is backed up by the industrial hammer of kill-to-loss ratios. The P-51 was, quite simply, an ace-maker. Prior to the P-51's arrival in force, the 8th Air Force was struggling. Its P-47 seconds were durable and deadly, but they were not achieving the kill ratios needed to break the times Luftwaffe *. The P-51 changed the arithmetic of the air war. In the first half of 1944, the period of the Great Berlin Raids, the P-51 groups began posting staggering numbers. The 357th Fighter Group, Bud Anderson's Green Unit, shot down 595 enemy aircraft in just over 14 months of combat, producing over 40 aces. The 4th Fighter Group, Blakesley's Hunters, claimed over 1,000 air and ground kills, the most of any group in the 8th. The combined statistics for the 8th Air Force show that P-51 seconds were credited with 4,950 of the 9,800 total air-to-air kills, just over 50% of all victories, despite not arriving in theatre until the war was half over. Its overall kill-to-loss ratio was a staggering 11.6 to 1 inch air-to-air combat. The P-47 achieved a respectable 4.2 to 1, and the P-38 a 1.9 to 1. The Merlin-powered Mustang was, statistically, the most lethal killing machine in the sky. The view from the cockpit was one of sudden, undeniable technological dominance. The young men flying the Mustang knew they were in a superior machine. The British engine, mass-produced in America, was not just a piece of hardware. It was the heart of their confidence, the guarantor of their survival, and the tool of their trade. The Times Luftwaffe, Times pilots on the receiving end of this new weapon, had a very different and far more terrifying perspective. For the pilots of the Times Reichsverteidigung *, the defense of the Reich, the sky had once been their sanctuary. It was their home, their battlefield, and their sovereign territory. In 1943, they had savaged the unescorted B-17 formations with a brutal professional efficiency. By early 1944, that sanctuary had been violated, transformed into a hunting ground where they were the prey. The psychological shock of seeing American fighters, Times Mustangs, Times weaving their contrails over Berlin, Munich, and even Vienna was a blow from which the Times Luftwaffe Times would never recover. It was an invasion. It was, to them, the beginning of the end. The most profound and most candid assessments of this new reality came not from propaganda reports, but from the men who had to fly against it, Germany's top aces, the Times Experten *. These were not timid men. They were the most experienced and lethal fighter pilots in the world, men with hundreds of victories, who had fought over Britain, Russia, and Africa, and they were in despair. General Adolf Galland, the Times General der Jagdflieger Times, General of Fighters, was a brilliant ace and a fiery commander who constantly battled with Hermann Goering over the strategic mismanagement of his fighter arm. In his post-war memoirs, The First and the Last, Galland described the moment he knew, with chilling certainty, that the war was lost. It came in March 1944, as he stood on a Times Luftwaffe Times airfield and watched a massive, high-altitude dogfight unfold over his head. He saw B-17 seconds, and he saw the silver specks of his Bf-109 seconds rising to meet them. But then he saw something else. He saw swarms of P-51 seconds, which had not only escorted the bombers times to times the target, but were now low on fuel, strafing times his own airfield as they departed. The range, the power, the sheer audacity of the act broke him. He wrote, "When I saw the Mustangs over Berlin, I knew the jig was up. I knew the war was over." Johannes Steinhoff, another high-scoring ace and wing commander of JG-77, wrote with equal despair in his memoir, The Frightful Years. He described the agonizing, unequal nature of the combat. "We were simply overwhelmed," he wrote. The Mustangs appeared in numbers that were simply unbelievable. They were faster, they were more maneuverable at altitude, and they were always above us. This was the key. The Merlin's two-stage supercharger gave the P-51 the critical high-altitude performance that Galland's own Bf-109G, with its DB-605 engine, was struggling to match. The Germans were being forced to fight at 30,000 feet, an altitude where the Merlin Mustang was in its element, and their own aircraft were sluggish and underpowered. This technological and numerical superiority created the Times, Verblutung, times the bleeding. The Times Luftwaffe Times could, perhaps, have sustained the loss of aircraft. What it could not sustain was the catastrophic, irreplaceable loss of its Times, Experten *. The American P-51 pilots were, by 1944, highly trained. They arrived in theatre with 400 or 500 hours of flight time. When a P-51 was shot down, the pilot was lost, but a new, equally well-trained pilot would take his place in a new aircraft within a week. The German system, starved of fuel, instructors and time, was in a death spiral. By 1944, the Times Luftwaffe Times was throwing teenage boys into the sky as cannon fodder. These new pilots had, if they were lucky, 100 hours of total flight time, often with barely 10 hours in a high-performance fighter. They were not trained in formation flying, gunnery, or high-altitude tactics. They were, as Steinhoff bitterly recalled, trained only for the slaughter. They were sent up, wave after wave, into the teeth of the American fighter sweeps. They would be annihilated by P-51 seconds diving on them from 10,000 feet above, often shot down before they even saw their attacker. The times, Verblutung times, was not just a loss of material, it was the systematic, industrial-scale execution of a generation of German pilots. Faced with this conventional annihilation, the German High Command turned, in desperation, to its wonder weapons. The two most promising were the Messerschmitt Me 163 times Comet Asterisk, a volatile rocket-powered interceptor, and the Messerschmitt Me 262 times Schwalbe Asterisk, the world's first operational jet fighter. On paper, the Me 262 was an untouchable revolution. It was over 100 miles per hour faster than the P-51. Galland himself flew it, and called it a gift from heaven, as if an angel were pushing. But the industrial and statistical hammer of the P-51's victory is this. The Me 262, while a technological marvel, was a strategic irrelevance. And it was the Merlin Mustang that made it so. The P-51, with its long range and Merlin engine, had a new mission: air supremacy. Doolittle's pilots were no longer just escorting bombers. They were free hunting, and their favorite hunting ground was the airspace, times around, times the Me 260, two airfields. The jet was vulnerable. It was a pig on takeoff and landing, slow to accelerate and slow to decelerate. Its primitive Junkers Jumo 004 engines slow to respond. P-51 pilots from the 4th and 357th Fighter Groups would orbit the jet bases at 30,000 feet, waiting. The moment an Me 262 was spotted in its landing pattern, the Mustangs would dive, their Packard Merlins at full power, and tear the jet apart before its wheels touched the ground. They strafed them on the runways. They destroyed them at their dispersal points. The Me 262 was a shark that could not survive the shallows, and the P-51 owned the entire ocean. From the German perspective, the Merlin Mustang was a nightmare. It was not just a better fighter, it was a plague, a relentless, omnipresent instrument of their destruction. It was the fork-tailed devil, the P-38, that had failed to materialize, a long-range killer that hunted them from the stratosphere to the tarmac. It was the weapon that bled their aces, slaughtered their youth, and strangled their jet-powered miracle in its cradle. The cockpit over Berlin was the point of decision, but the war was won 1,000 miles away, in the thundering, fluorescent-lit caverns of Detroit, Michigan. The victory of the P-51 Mustang was not just a feat of Anglo-American engineering. It was a brutal, decisive triumph of industrial philosophy. The Times Luftwaffe Times was not merely out-fought, it was out-produced, out-organized, and ultimately out. Built by an industrial hammer it could neither comprehend nor match. The heart of this hammer was the Packard Motor Car Company. When Packard's president, George T. Christopher, and his chief engineer, Jesse G. Vincent, first uncrated the pattern Rolls-Royce Merlin in 1940, they were looking at a piece of European artistry. It was an engine built by craftsmen, with tolerances and fits left to the skilled hands of Derby artisans. As Vincent's team began the translation to American mass production, they were, in his own words, re-engineering it for American production. This was not just a matter of changing screw threads. It was about creating a system where a worker who had never seen a complete engine could produce a single, perfect, and 100% interchangeable component. Packard invested $100 million in tooling, creating vast, automated assembly lines. They invented new gear-hobbing machines to mass-produce the Swiss watch gears of the two-stage Supercharger. They developed new metallurgical processes to forge crankshafts and connecting rods at a rate Rolls-Royce could only dream of. Where the Derby factory was a workshop, the Packard plant was a river. As George T. Christopher stated to his workforce, "We are not just building an engine, we are building the times means times to build the engine." This philosophy of interchangeable, rapid, and scalable production was America's single greatest weapon. On the other side of the Atlantic, the German war machine was a study in contrasts. Albert Speer, Hitler's Minister of Armaments, was a logistical genius, but he was papering over a system that was fundamentally flawed. In his post-war interrogations and memoirs, Speer detailed the catastrophic inefficiencies. German industry, much like the Rolls-Royce model, was reliant on skilled artisan labor. But by 1944, those skilled laborers were being conscripted and fed into the meat grinder on the Eastern Front, replaced by unwilling slave labor. Furthermore, German aircraft production was a fractured, chaotic mess. Instead of standardizing on one or two proven models, the Times Luftwaffe asterisk, at the personal whim of Goering and Hitler, was constantly demanding new, technologically advanced wonder weapons. This meant resources were constantly being diverted to complex, unproven designs like the Me-262 jet, which required specialized alloys and production techniques, instead of mass-producing the proven F-190 or Bf-109. And then came the P-51 seconds. The daylight bombing campaign, which the Merlin Mustang had made possible, was now strangling the Times Reich asterisk. P-51 seconds were not just killing Times Luftwaffe Times pilots. They were enabling the B-17 seconds to systematically obliterate the component factories, the ball-bearing plants at Schweinfurt, and the synthetic oil refineries at Ploesti. Speer's own reports from 1944 are a litany of despair, chronicling the collapse of fuel production and the dispersal of factories into tiny, inefficient workshops hidden in forests, a desperate, last-ditch effort to escape the bombers that the P-51 seconds were guiding to their door. The final, industrial hammer is found in the raw production numbers. The statistics are not just numbers, they are the death warrant of the Times Luftwaffe asterisk. By the end of the war, the Packard Motor Car Company, a luxury car builder, had produced 55,523 of its V-1650 Merlin engines. This staggering number was in addition to the 57,000 Merlins built by Rolls-Royce in Britain. The total production for Germany's best equivalent engine, the Daimler-Benz DB605 that powered the Bf-109, was approximately 42,000 times of all variants asterisk. The Allies had not just matched, but overwhelmed their enemy in the single most critical component. The airframe numbers tell the same story. North American Aviation, at its plants in Inglewood, California, and Dallas, Texas, produced over 15,000 P-51 Mustangs of all models. The total, entire wartime production for the Focke-Wulf 190, the Times Luftwaffe's Times Best all-around fighter, was approximately 14,000 times of all types asterisk, including ground attack and prototype versions. The P-51, an aircraft that didn't even exist in its final form until 1943, had, in less than 2 years, outnumbered one of Germany's primary fighters. The Times Luftwaffe Times was crushed under an avalanche of aluminum and steel. The British Merlin was the perfect heart, a masterpiece of engineering. But it was the American industrial hammer, the uniquely American ability to take that masterpiece, translate it, and then build it by the tens of thousands on a roaring, unstoppable assembly line that truly won the air war. The victory of the Merlin Mustang was a clean, decisive line on a performance chart. In the sky over Berlin, it was a matter of life and death. But on the ground, in the smoke-filled offices of Washington, and at the test facilities of Wright Field, Ohio, it was the result of a second, far more complex battle. This was the dual conflict, a war fought not against the Axis, but against institutional pride, industrial politics, and the powerful not-invented-here syndrome. The P-51's British heart was not just a technical solution, it was a political problem. The US, Army Air Forces, in the 1930s and early 42nd, had invested its entire institutional ego into two distinct branches of engine technology. First was the air-cooled radial, the brute force American icon. The Pratt & Whitney R2800 Double Wasp, a massive 18-cylinder engine, was the heart of the P-47 Thunderbolt and the F-4U Corsair. It was tough, reliable, and quintessentially American. The second branch was the liquid-cooled V-12, and here, the USAAF's chosen champion was the Allison V1000 710. This was the engine in the P-38 Lightning, the P-39 Airacobra, and the original, failed P-51 Amperes. When the British Mustang X data arrived at Wright Field in late 1942, the engineers at the USAAF's Material Command, led by figures like General Oliver P. Eccles, were impressed, but also deeply skeptical. Their institutional mandate was to foster and perfect times American times industry. The suggestion that their premier fighter airframe, the P-51, was a failure without a foreign engine from Britain was a bitter pill to swallow. It ran counter to the entire narrative of American industrial and technical supremacy. There was a powerful, unspoken resistance to admitting that Rolls-Royce had solved a problem high-altitude supercharging that America's own Allison had failed to. The USAAF's first response was not to embrace the Merlin, but to challenge it. They initiated Allison's Last Stand, a high-priority project to give the V1710 the high-altitude lungs it so desperately needed. The USAAF funded Allison to develop its time-zone times two-stage supercharger. This project was a technical success, resulting in engines like the V1710121. This was a magnificent piece of engineering, lighter than the Merlin and with a superior supercharger design. It was slotted into the lightweight Mustang variants, the P-51 Farrads and P-51 Hours, aircraft that were, on paper, even better performers than the P-51D. But this is the crucial, tragic irony. The American solution, while brilliant, was too little, too late. The war in Europe was being fought and times won times in 1944. The P-51 Hours, powered by the all-American two-stage Allison, would not reach operational service until after VE Day. The P-51 seconds that were actually breaking the times Luftwaffe times over Berlin were the B and D models, powered by the foreign Packard Merlin. The institutional pride of Wright Field had successfully produced an American marvel, but it had missed the war. The second front of this dual conflict was fought not by engineers, but by pilots, in the internal debates of the 8th Air Force itself. This was the P-47 Jug lobby. While Doolittle and Blakesley of the 4th Fighter Group were early, rabid proponents of their new Merlin Mustangs, many of the 8th's most successful and powerful commanders were devotees of the P-47 Thunderbolt. Men like Colonel Hub Zemke, the legendary leader of the 56th Fighter Group, Zemke's Wolf Pack, swore by the Jug. Their argument was not based on performance charts, but on brutal, bloody experience. The P-47, with its air-cooled R2800 engine, was a flying tank. A P-47 could absorb a cannon shell from a Bf-109, have several of its 18 cylinders shot away, and still limp its pilot home. The P-51, by contrast, was a thoroughbred with a glass jaw. Its liquid-cooled Merlin, like the Spitfires, was its Achilles heel. A single, lucky, 50 caliber round from a German fighter, striking the P-51's complex radiator system, or a coolant line, was a death sentence. The glycol would bleed out in minutes, the Packard Merlin would seize solid, and the pilot would be on the silk, parachuting into enemy territory. This debate raged in the mess halls and, more importantly, in the command huts of the 8th. Was it better to have the P-51's high-altitude performance and range, or the P-47's rugged, get-you-home-at-all-costs durability? The P-47 lobby had the industrial and political weight of Pratt & Whitney and Republic Aviation behind it. The P-51 had North American and Packard. For a time, the P-47, fitted with new paddle blade propellers and massive external drop tanks, was almost keeping pace with the P-51's range, albeit at a much higher cost in fuel. It was the P-51's raw, undeniable combat data from the spring of 1944 that finally ended the argument. The kill-to-loss ratios being posted by the Mustang groups were simply too high to ignore. The P-51 was not just a better escort, it was a better killer. It had the performance, the range, and the agility to execute Doolittle's hunt and destroy doctrine in a way the heavier, slower-climbing P-47 simply could not. The Merlin Mustang's success, therefore, was not just a technical miracle, it was a political one. It had to overcome the institutional pride of the USAAF, which wanted an all-American engine, and it had to overcome the powerful, well-funded lobby for the more durable P-47. The P-51B, a hybrid of a British heart and an American body, had to win two wars, one against the Times Luftwaffe times in the sky, and another against bureaucracy and national pride on the ground. We return to the cold, thin air above Wright Field, Ohio, in the summer of 1942. We see a test pilot, his face a mask of disappointment, fighting a sleek, beautiful airframe that is gasping for breath. The Allison-powered XP-51 is a racehorse suffocating in a vacuum, a masterpiece of design shackled to a crippled heart. It is a failure. Now, we shift. The time is March 1944. We are at 30,000 feet over Berlin. We see a swarm of silver predators, their noses marked with the checkerboards of the 357th, the red tails of the 4th. A young pilot, perhaps Bud Anderson in Old Crow, kicks his rudder and lines up a Focke-Wulf. His Packard Merlin engine, the British heart in this American body, is not just breathing, it is times screaming, times with power, a high-altitude banshee. This is not a failure. This is the apex predator of the skies, the single machine that is systemically and with cold industrial efficiency executing the Times Luftwaffe times in its own home. This transformation is the story. As we stated at the beginning, the P-51 Mustang, an aircraft that would become the single greatest icon of American airpower, was born a profound failure. Its revolutionary body housed a crippled heart, the Allison V1710 engine, a power plant that made it useless for the very war it was destined to win. This story was never one of American ingenuity alone. It was the story of an Anglo-American gamble, a desperate engine swap that transformed a grounded thoroughbred into the apex predator of the skies. The victory had two fathers. On one side, the American genius of North American aviation, the vision of Dutch Kindleberger, and the aerodynamic brilliance of Edgar Schmood, who designed a perfect airframe. On the other, the British genius of Rolls-Royce, the mathematical foresight of Stanley Hooker, and the keen, observant eye of a test pilot named Ronald Harker. The men who flew it, the men who survived because of it, understood this dual heritage. Colonel Bud Anderson, the quintessential American ace, spoke with reverence, not just of his P-51, but of its smooth, powerful Packard Merlin. He and the pilots of the 4th Fighter Group, who had flown British Spitfires in the RAF, knew exactly what that Merlin meant. They knew it was the source of their power, the engine that gave them the confidence to engage and win at 30,000 feet. On the British side, there was a quiet, professional pride. Stanley Hooker, the engineer who had perfected the two-stage supercharger against all internal resistance, would later reflect on the Packard V1650. He examined the American-built engine and, with an engineer's eye for quality, noted the superb mass production techniques. He saw his craftsman's engine had been successfully translated into an industrial miracle. The alliance was not just political, it was metallurgical. It was an admission of mutual dependence, a fusion of British innovation and American industrial might that no Axis power could hope to match. The legacy of this fusion is almost immeasurable. The P-51 Mustang became the definitive symbol of American air power. It was the aircraft that not only won the war in Europe but went on to serve in Korea, fighting jets, and in air forces around the world for decades. It became the aspirational aircraft, the one every hotshot pilot wanted to fly. But its most important legacy is the one born from its initial, catastrophic failure. The Allison Albatross, the grounded racehorse, was a crucial catalyst. Had the P-51 Amperes been good enough, had it been a mediocre but usable fighter like the P-40, it would have been relegated to secondary fronts, a footnote in aviation history. It was its profound times inadequacy at high altitude that forced the hands of men like Ronald Harker. The failure was so stark, so complete, that it demanded a radical solution, and in doing so, it forced the creation of a legend. The industrial and statistical hammer that sealed the victory is the final, brutal epitaph for the Luftwaffe asterisk. The 8th Air Force in total was credited with 9,800 air-to-air kills. Of those, the P-51, an aircraft that did not even arrive in theatre until the war was half over, was credited with 4,950. One single aircraft type, powered by one specific engine, was responsible for over half of all aerial victories. It was the P-51, the Merlin Mustang, that broke the Luftwaffe's times back over Berlin. It was the P-51 that bled the experten times dry. And it was the P-51 that swept the skies of France, clearing the air for the D-Day landings, ensuring that not a single Allied soldier on the beaches was strafed by a Luftwaffe plane. In the end, the P-51 Mustang is a story of contradictions. It was an American icon with a British heart. It was a mass-produced industrial product that performed with the precision of a craftsman's tool. And it was, most importantly, a legendary success that was born from an unmitigated failure. The Mustang airframe gave America a weapon. The Merlin engine gave that weapon its soul. Together, they created a machine that did more than just escort the bombers. It hunted, it dominated, and in the skies over the dying Reich, it won the air war.